Alright, so let's have a look at 1.9. This is 2D representations of 3D figures. In other words, what you're going to be doing is isometric and orthographic drawings and nets. Okay, just a little vocabulary, that's all. Just the orthographic drawings and a net. You probably would have done nets many times in lower schools. So, but anyway, let's have a look at what you do. Take the figure, and generally all you're going to do is rotate it. You're going to always start from the top, the left view, the front view, and then the right view. So, and build it up as you're going along. You'll see as we do it in a few minutes. So now we're going to be looking at making models from the drawings. You will be given isometric paper, so it will make it a lot easier for you. You have to look for clues, so the clues are the darkened blue lines in the diagrams above. So in the top, you've got different, that tells you that you've got different levels, and the same with the front and the same with the right side. The only thing that isn't different is the left view, so you know that you're going to have a complete block of 2 across and 3 across and 2 up. So the back, in fact, that's going to be the back view for when you draw it. So again, I'm going to try my best and do it freehand, but you will be given isometric paper, as I said. Okay, and these are all going to be different blocks. So you're going to be coming along here somewhere along this. You've got an extra one here, because don't forget the top view says that you've got 3 wide. You're going to come out an extra one, you're going to go down, and you can see how we're building it up, all right? But you have to look at the clues that's in the diagrams as far as building it up, and then eventually you will have a 3D isometric picture. Okay, the second thing we're going to look at is drawing nets. You've all done nets before, okay? And nets will be in different sort of ways depending on which way you cut it. Okay, so here in example 2, you've got a triangular prism, a Toblerone type of thing. You've got several ways that you can do it. Okay, so for instance, you can actually put the end bits out that way. Okay, and you'll have the base, which will go here. All right, then you'll have the back, which is going to go next to it, which should be the same size as that. And then you'll have the front, which is this part here. That's slightly bigger. So you can have a net like that, or you can do it the way that they've done it in the diagram. So in other words, all it is taking your shape and then cutting it, putting lines into it and just opening it up. Okay, so when you've been given a net and you have to identify the solid, you need to look for clues, okay? So let's have a look at number 2. First and foremost, you've got 6 sections. Well, start thinking of 6 sections. The only thing you can think of really is either a cube or a rectangular prism. Okay, so let's have a look at what it can be. It can be a cube, okay, and it can be a rectangular prism. So which is which one's it going to be? Again, go back to the diagram. As you can see, all these 6 sections are all the same size, so the only thing it can be is the cube. It cannot be the rectangle. Okay, and then obviously in question number 3, what you're looking for here is the fact that you've got 2 circles. You've got one here and one here. Okay, start thinking of shapes where you've got circles, and what you will have is actually a cylinder for that one. Where the 2 circles are the top and the bottom, and this part here is, if you think about it, a kind of food, beans or something, fruit. That's going to be your label, okay? And then going in the opposite direction, this is drawing nets from solids. Okay, so look for what you've got. So for instance, you've got a pentagonal prism in the diagram here. You know you're going to have 2 bases, the top one here and the bottom one here, so that will come out into this part here. There's base 1 and here's base 2, and then obviously you've got 5 sides. And look for notation. As you can see in the notation on the top one, they're all the same size, so this is why you've got 5 that's all the same length. Okay, So again, you could have it slightly different. You could actually put the bases on the ends here. It doesn't really matter. You will still get the shape. All right, so let's have a look at what you've got for question number 4. Basically, this is identical to your example. This time you've got a hexagon, so if you draw it like they did in example 3, you're going to have 2 hexagons. All right, a hexagon's got 6 sides, so it doesn't matter. You can do 2, 3 that way, 2 this way, it doesn't matter, okay? And like I said, you can move it, looks like an angel. So for a Catholic school, that looks really good.